So I'm Elizabeth C. Carley, and I was a high school math teacher for 9 years, and I used Sketchpad in my teaching. And now I work for Key, and I get to do these fun webinars. So that's how I came to Key, was mostly through Sketchpad. Now I'm going to hide the people. No offense to you guys and me. I just wanted to show this quote from the Common Core State Standards. It says, dynamic geometry environments provide students with experimental and modeling tools that allow them to investigate geometric phenomena in much the same way as computer algebra systems allow them to experiment with algebraic phenomena. So I like this because I like the use of investigate and experimental there. Kind of in. Oh. I'm getting some funny noises in my headphones.
Elizabeth, your volume is really low according to some people, and you seem to be fading out.
Okay, how's that? Better?
No, now you went. For me, you went down even lower.
Oh boy, this isn't good because I can't really. How is that? No, I can barely hear. Can I keep my voice constant? I'm pretty much talking at the same level, so I'm wondering if it's a connection.
Probably it's your headset, maybe.
Ooh. All right, I'm gonna try. Let me try this.
Does Andres have a? Elizabeth happens to be in our main offices. Does Andres happen to have a headset that you could borrow that might work better?
This is. So you're not hearing me clearly right now? Fine for me, just quieter than you. Okay, I'm getting kind of mixed feedback in the chat panel. Karen's really loud. So maybe if y'all could turn up your volume, and Karen, maybe if you can back away from the mic a little bit when you talk, so they're not getting the Disney Channel effect. Okay, so hopefully you go loud, then soft, then really loud, then very soft. Okay, so here we go. I'm gonna use this as kind of my guiding principle that we're gonna be experimenting a little bit with geometric phenomena today. We're gonna use Sketchpad as our tool to do that. Okay, so agenda for today, gonna give you a little overview, which I just started to do and then got interrupted by all the volume. Hopefully you can all hear me now. I'm going to take a poll to figure out who's in the audience, and we're going to be looking at some standards from grade 7, grade 8, and from high school, and exploring those standards using Sketchpad. Okay, so first thing I do want to do is launch a poll and get a little bit of information about who is here today. So I'm going to start by asking about your experience with Sketchpad. So a poll should have come up on your screen. Go ahead and answer that. And every vote counts, so please do respond. I'm going to wait for another couple seconds. I have some shy people, I think. Okay, almost 90% have voted, so that's good. And let's share those results. Okay, so we have 17% completely new to Sketchpad and 36% are beginners. Okay, so if I'm doing my math correctly, that's over half of you who are completely new or beginning or have seen it used but haven't used it yourself. So I want to make sure that I'm meeting the needs of those folks. So if you're an intermediate user or a rock star, there may not be much new for you today, but you are free to chime in with hints and your experiences. I would love for you to do that in the chat panel, and I'm happy to have all of you here. Okay, and I know there's at least one rock star user out there that I know of, so that's confirmed. Okay, I'm gonna give another. We don't have to know who's declaring themselves a rock star. We can keep that information private, right? Let's see, another question I have is just what grade level is your primary focus? And if you're a supervisor of teachers, you could put the level that you supervise. If you supervise elementary teachers, you might put that elementary school down, just kind of your general grade level of interest. Okay, and we're getting close to 90% having voted, so I'm going to close this and share it. And we have the majority of folks in high school and some elementary teachers or supervisors here as well. I'll be looking today at middle school and high school standards, but just know that we do have webinars that cover more elementary topics. And so if you're intimidated by the content level today, don't worry about it. We'll have something for you soon. And one more poll, again, just to give me some information. And this is, do your students do compass and straight edge constructions? Interesting. Okay, and let's see. So we have almost 70% say yes, their students do compass and straight edge constructions. I'm guessing the elementary folks don't do compass and straight edge constructions, but this is great to know. It seemed like compass and straight edge constructions were kind of going out of style when I was teaching geometry. So I was just really curious to see whether people are doing them or not, and it's good to know over half of you are. Okay, about 2/3 actually. Alrighty, so I'm going to go on with my presentation now that I have a little information about you. Okay, oh, and I have a... Okay, and since this is a Common Core focused webinar, I will be looking at how Sketchpad can be used to address concepts in the Common Core and how it might kind of change the way that you address concepts. So it won't be a lot of how to do really complex things in Sketchpad. We're going to do a lot of more simple sketches from scratch to see that it's pretty easy to get started with Sketchpad when you're looking at congruence and similarity and transformations. So this is from the Standards for Mathematical Practice, Use Appropriate Tools Strategically. Just want to point out a couple of things here. Mathematically proficient students consider the available tools when solving a problem, and that would include perhaps dynamic geometry software like Sketchpad. And this seems really important to me. Proficient students are sufficiently familiar with the tools to make sound decisions about when each of these tools might be helpful, recognizing the insight that they can gain and their limitations. And so really for students to be able to be familiar enough to choose a tool, it means they have to have used the tool, not maybe just seen it as demonstrated in class, but actually had the time to work with the tool, maybe in a computer lab, on a laptop. So I know that not everybody's able to do that because we don't all have the computers we need for our students, but that's really the goal stated in the Common Core. So hopefully everybody will be getting those resources as states implement the Common Core. Okay, so I'm going to start with the 7th grade standard, draw freehand with ruler and protractor and with technology, geometric shapes with given conditions. And we're going to think about congruent triangles right now. So we're going to be constructing triangles using a couple of methods. I'm going to hide this to make a little bit more space. Now, Sketchpad 5 has a Polygon tool, which is super handy. So I can just select the 3 vertices, and I have a triangle there. And I can choose my color, customize it as I want. And for those who haven't seen Sketchpad before, when you construct a triangle in Sketchpad, you've really constructed every triangle. So I can drag the vertices of triangle ABC, and I can make it obtuse, I can make it right, I can make it acute, I can make any triangle I want by dragging the 3 vertices. What I'm going to try to do is construct a congruent triangle, and I'm going to start as if I were a 7th grade student with some help from their teacher. And I'm going to try constructing a triangle that has 2 sides congruent to 2 sides of triangle ABC, and I'm going to see what kind of relationship those triangles have. So just like with a compass and straight edge, if we want to construct a congruent segment, we need to make an arc, but really what we're doing is we're making a circle. So I'm going to choose point D, and I'm going to choose my first side, AB, and I'm going to construct a circle using D as the center and AB as the radius. Okay, and now what I've done, if I construct a radius for my circle, is I've constructed a segment ED that's the same length as AB, and the length of AB controls the length of this circle and therefore the length of the radius. So if I change AB, I'm also changing ED. I'm going to go ahead and make these guys all thicker so we can see them better. Okay. So I'm moving this around so that you can sort of see the behavior now, that no matter what I do with segment ED, I can't change its length unless I drag the controlling segment. Okay, so I'm going to make a second side that's congruent to the second side of triangle ABC. So again, starting with point D, I'm going to construct a second circle. And now if I construct that radius, I have a segment that's congruent to BC. So again, if I drag BC, you can see that segment DF is changing correspondingly. Now normally I would hide these, but because we have a lot of folks who are new to Sketchpad, I want to leave the construction circles visible. I'm just making them thin and dashed so that you can sort of see what's going on when I continue dragging things around. I'm going to use my Polygon tool and construct a triangle now that uses these 3 vertices. And again, I can change things for appearance, like I don't really want a gray triangle. I think I want a pretty yellow one. Now, I've constructed segment ED to be congruent to AB, so I'm going to go ahead and mark that with a crossbar. Mark those the same way. And I've also constructed segment BC to be congruent to segment, I've constructed segment DF to be congruent to segment BC. So if I change either of those segments, you can see those segments in DEF changing correspondingly. Now the question is, are these 2 triangles congruent? Have I constructed them to be congruent? They kind of look congruent right now, and if I sort of match them up, I could maybe see if they match. They're congruent. Okay, and they are kind of looking congruent, but there's sort of a fatal flaw here, and that's that even though I can't change the length of ED, I can change that angle between ED and DF as much as I want, and now I clearly have 2 triangles that aren't congruent. So from this sort of experiment, students can see that if 2 sides of one triangle are congruent to 2 sides of another, it's not sufficient to say that those 2 triangles are congruent. And if I were exploring this as part of an assignment, I could use hot text to explain that. So I've just clicked on triangle ABC, and I'm going to write a little explanation of what I've discovered. Triangle ABC is not congruent to triangle DEF because, for example, CA and EF are not congruent. Okay, now with hot text, if I click on the text, I don't know if you can see, but triangle ABC is flashing, triangle EDF is flashing, the segments flash. So this is nice if you have an interactive whiteboard. You can use this as a nice demonstration tool to do an explanation to the class. You are one of your students. Okay, so side, that didn't work. So I'm gonna start on the new page and quickly kind of duplicate what I just did, but I'm going to go on and try to do side this time. So I'm sort of reviewing what I've just done. So I'm going to, with a starting point, I'm going to select segment AB and construct a circle. And I'm going to go ahead and construct a radius. So now I have a side that's congruent. And I'm going to construct a second circle. Now here's where it gets a little interesting. I want to construct a third side. So this time I'm going to use point F as my center. And I'm going to select AC. And I'm going to construct a third circle, so one circle for each side. But notice that I'm now, I've got my point E here, and point E is not connected to that third circle unless I place it right here. But in Sketchpad, you need to define a point to be at the intersection. So rather than just dragging a point to the intersection, what I want to do is actually construct a point at that intersection. And you can see as I go over the circle, the right circle is red. That means that if I click on point G right now, it will be on that red circle. If I want to click on if I want to get it right at the intersection point, I need to make sure that both circles are highlighted red. Okay, so now that third vertex is going to be situated such that DG is congruent to AB because it's on this circle, and FG is congruent to AC because it's on this circle. And I'm going to go ahead and use my Polygon Tool to make a triangle. And this guy, it turns out I don't really need it. I can either delete it or hide it. But I have to be a little bit careful because if I delete one of the circles that I've used to construct, I'm going to show you what happens. Oops, my triangle goes away because it was defined based on that circle. So I'm going to choose Edit, Undo. And instead of deleting, I'm going to hide. And just to be absolutely safe, I'm just going to go ahead and hide that. Now, I'm going to use a Hide Show button so that you can see how I did this later, because I'm going to save this sketch. So if I click my Hide Show button, the construction objects are gone, but when you're taking a look at this later, you can see what was involved. So if I've done this construction correctly, and I know a little bit of geometry, I now should have constructed DFG in a way that it will always be congruent to triangle ABC. And I can check that by superposition, by positioning my triangle so it's right on top of the other one, and that's a way of checking by translation, which is one of the things the Common Core asks students to do. If you can translate an object and superimpose it, then they're congruent. Okay, and now because it's dynamic geometry, any triangle that I form by dragging the vertices of ABC will be congruent to DFG because I've constructed DFG to be congruent. Okay, now I'm going to show you a little trick. This is for the non-beginners, and I hope that it's going to work because I always feel like I'm taking a chance when I do a custom tool. So I've just constructed a tool. I've just constructed a triangle using the three sides of this triangle to construct a congruent triangle. So what I'm going to do is I'm going to select this entire triangle, and then I'm going to select sort of the givens, the things that I needed to construct it. And what I needed were three sides of another triangle. And down here on the tool menu, I'm going to create a new tool, and I'm going to call it Side, 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 or SSS Triangle. And I'm going to select that tool, And I believe that if I've done it correctly, I select a starting point, and I select 3 segments, and it will construct a triangle using those 3 segments. So what I've just done is I've sort of magically recreated my construction steps to construct another triangle congruent to triangle ABC. And now that I've constructed that tool, every time I open this sketch, that tool will be available for me. So students can do this too. I can use that tool in a new context here. I've got my side, side, side triangle tool. And again, I'm going to indicate my starting point. And then I'm going to select these 3 segments to be my 3 sides. And now I've got a new triangle that has these 3 sides as its side lengths. And you can kind of play with it and see that nothing about this triangle is going to change except for its position or its orientation until I drag one of the 3 defining segments. And what I think is it's kind of cool is that I can break this triangle. What just happened? Well, this has to do with the triangle inequality theorem, right? This 3rd side of the triangle can't be longer than the sum of the other 2 lengths. So the nice thing in Sketchpad is you might think, oh no, my tool doesn't really work, but actually my tool works perfectly. It follows the principles of a triangle, right? So I'm giving you this side, side, side tool in the sketch, but you can make it yourself. Try it yourself. All right, let's pause for a second for questions. I haven't been looking at the chat panel at all. So tell me if there are any questions.
I know you're doing pretty good. Everyone's kind of answering their own, and I haven't seen any. If you have a question right now you want to ask Elizabeth, send it real quick in the chat panel. If not, I say keep on going.
Keep on going? Okay.
I don't see any.
I did notice a comment about confirming with measurement, and I want to, for those who are new, we can absolutely confirm with measurement. So I'm going to go ahead and measure side lengths, and I can sort of see what's going on there, and I can see that sure the side lengths, and I can also measure the angles. I'm hearing you muting and unmuting, Karen. Is everybody
I know
that?
this is the problem with both of us being the same name, unfortunately. I can't turn myself off. It keeps turning you off.
Oh, okay. That's fine. I don't think everybody's hearing that, right? Anyhow, so we can measure sides and angles, and we can confirm that no matter how I manipulate triangle ABC, and you can see the other triangle I constructed is following it. I'm going to delete that guy for now. No matter how I manipulate triangle ABC, each corresponding side is congruent. Each pair of corresponding sides is congruent. So I saw something about measurement, so I thought I would just mention the measurement capabilities. Okay, I think I'm going to skip this for now and maybe come back to it. We can also construct a triangle using side angle side, but I'm worried that we are going to run out of time if I do everything. So I'm going to skip that for now, and I can put it in the sketch that we distribute. Okay, so we just took a look at a 7th grade standard, and now we're going to take a look at an 8th grade standard. Again, understand congruence and similarity using physical models, transparencies, or geometry software. So dynamic geometry software comes up a lot in the Common Core, particularly in the geometry standards. So we might as well try to use it, right? And I would say, again, to kind of focus on experimentation, that you can do some simple playing in Sketchpad that helps you sort of understand what's going on with different transformations. And just for a quick example of that, this particular standard says lines are taken to lines and line segments to line segments of the same length. Angles are taken to angles of the same measure. Parallel lines are taken to parallel lines. And right now we're talking about rotations, reflections, and translations. So rigid transformations right now. So if I construct a triangle, and let's, since we have something about parallel in there, I'm going to go ahead and construct a segment that's parallel to one side of the segment, one side of the triangle. Okay, so what I've done is I've constructed a parallel line. So no matter how I move point D, it will remain parallel to BC because I've constructed it to stay parallel. I'm going to construct a segment from D to the intersection of the parallel line with the triangle side. So now I have a segment that will remain parallel no matter how I manipulate the triangle. And I can go ahead and hide that construction line. Don't have to hide it, but I'm going to hide it in this case. Okay, so I've constructed it to be parallel and it will stay parallel. So I'm going to make a little bit more space by hiding my caption. I'm going to start by trying reflection. And in order to reflect an object, I need a line of reflection. So I've just used the line tool to construct a line. And to mark that as the line of reflection, I can either select it and from the transform menu choose mark mirror, and you'll see it kind of flash, or I can just double click it and it does the same flash, and so I just marked it. And I've chosen my mirror, so I'm going to go ahead and draw a selection box around my whole figure there. And again, from the transform menu, I'm going to choose reflect. And you can see that I've got a reflection of my triangle ABC there. And any point that I drag in my image is going to be reflected. Okay, and this alone can give me some ideas of what goes on when I reflect across a line. For example, if I pick up my whole object and move it closer, I can see that at the point when one of my vertices touches the line, my reflection of my image are going to match up right there. And I can also see that anything that I drag will drag in the reflection. Now, I'm going to go ahead and measure these lengths first to see if the segment lengths are preserved by the reflection. And I can see that they appear to be. And again, the advantage of dynamic geometry is I can then sort of change them and see, well, once I've changed this triangle, are the corresponding lengths still the same? And I can see that they are. J and J prime are the congruent, and K and K prime are congruent. Now, it also says something about slopes. So to investigate that, I'm going to measure the slopes of those four segments. And what happens when I measure slopes, as you'll see, is a coordinate system comes up, okay, because we need a reference for our slopes. And so it brought a coordinate system up, and you can see that the slopes of J and K are about -1/3, and the slopes of J prime and K prime are 0.38. So in that standard, it wasn't saying that the reflection of a segment will be parallel to it. It was saying that if two segments or lines are parallel within a figure, the corresponding segments will be parallel within the reflected figure. So that just gave me a little bit better understanding of that standard, actually, just playing with Sketchpad. Okay, so again, just kind of easy to get started with just a basic understanding of rigid transformations. Now, I'm going to show a couple ways that you can play with it. I'm going to actually bring up a graph under the graph menu, define coordinate system, and I'm setting it to snap points because that'll make it a little bit easier to explore. And I'm going to construct a triangle. again. I can choose whatever color I want. Now, because I've chosen snap, have I chosen snap points? No, I unchose snap points. Because I've chosen snap points, you can see that the triangle will kind of click into place, and that just makes it nice because I'll get kind of pretty coordinates when I measure. In fact, I'm going to go ahead and just go ahead and measure my coordinates right now. Okay, so we were just looking at reflection, but I actually want to take a look at translation now. One way to do a translation is just select a figure, and in the transform menu, choose translate. And you can see that I have a choice of polar, rectangular. We're looking at 7th, 8th grade here, so I'm going to choose rectangular. And you can see where the translation is going to be. You can see sort of the shadow of it. And as I adjust my horizontal, I'm just typing these on the keyboard. If I adjust these, you can see things changing on the screen there. So I'm going to move it down farther so that it's free. And I'm going to go ahead and click Translate. And now I have a translation of my triangle there. And this translation will actually move the original triangle. Okay, interesting, huh? So I can measure these 3 coordinates, and I can look at the relationship between the 2 figures and their coordinates of the vertices. However, what I prefer to do for translations is something that's a little bit more flexible, and so I'm going to construct a kind of a controlling segment here, and I'm going to select the start of my segment and the end of the segment, and I'm going to choose Mark Vector. And watch the segment right now. You'll see a little ripple. Okay, so I'm defining that to be my translation vector. I'm going to select my figure again. And now when I choose Translate, notice that I have marked selected. I could go back and choose rectangular again, but I want to use my marked translation vector. So now when I translate, I'm going to change my color there. Ooh, change the sides too. That's bright. I can actually control the translation by moving that endpoint. Okay, and that is pretty powerful. One thing that I might want to do is measure the coordinates at point O so that I can understand what the horizontal and the vertical units are there that I'm translating. And then I also probably would want to measure the coordinates of my translated figure there. And so I can sort of see what's going on. What happens when I translate with a negative vertical but a positive horizontal, and really get a sense of what's going on and control it very, very directly that way. Okay, now for all of these translations, I can see that my figures are remaining congruent. And I can actually sort of place it right on top of each one to verify that. Or I can measure my sides and my angles. Okay, so all I'm doing here is just playing with translation. 2 different ways. You can either put the translation in by hand yourself, rectangular or polar, or you can make it using a vector, which I think gives you a little bit more control, and it makes it more dynamic. All right, questions? Let's see.
Sorry, I can't. My name like goes up and down because we have the same name. There's some questions actually that refer back to the marker tool. So a lot of people wanted to see how that works. So I don't know if you want to stop and do that now, if you want to come back to it. But some people wanted to understand how the marker tool makes the tick marks and the parallel line marks.
Yeah. Let me. I can show that as part of this next demo. How about that? I will incorporate that into this. Perfect. Anything else that I should incorporate?
There was a question that just came up about the values. You had integer values. How did you use only integers? So maybe talking about preferences a
Oh,
bit.
yeah. So here I have snap points is checked there. So if I didn't have snapped points checked, I would be able to move the vertices anywhere, and you can see the values are not as sort of clean. So I've checked snap points just because I think it's a little bit easier for students to then sort of see what's going on here. You know, what's the change from L to L prime. So again, snap points is making it land exactly on those sort of lattices. All right, and I'll show the marker tool right now as part of this, as part of looking at reflection again. So I want to take a look, another quick look at reflection. I'm going to make a, I don't know, kind of a kite-like figure, except for it can be mutated. I'm going to make a quadrilateral, let's just say that. And so a standard thing to explore is reflection across the axes. And again, I can select an axis and choose it to be the mirror, or I can also just double-click, and that will have the same effect. And if I select the figure and reflect it, I then I just reflected it across the y-axis. And I'm going to change my color. And I do have snap points selected, so again, it's going to snap into nice places, and it makes it a little bit easier. Okay, now I'm going to show you something fun. For those of you who have maybe used Sketchpad a little bit, but not a lot, this is kind of a neat trick. I'm going to choose point in the point menu. And now if I go to the edit menu, I can easily select all points. And now you can see that all my points on this page have been selected. I'm going to deselect these two guys because I don't need to measure them, but now I've got all 8 vertices selected, and I can measure the coordinates, and I just saved myself about 1 second, but I don't know, it's still very satisfying to know these tricks. Okay, so now I can take a look at what happens to the coordinates when I reflect across the y-axis. And again, I have snap points on, so they're landing on nice places. Now, the marker tool, new to Sketchpad 5, it lets you basically make the markings for congruent, parallel, all the things that those of us using Sketchpad 3 and 4 had to sort of make up ourselves, crazy custom tools. Now, Sketchpad 5 has it built in. So I'm just clicking twice with the marker tool to create 2 tick marks, and then I can do the same. Now, Sketchpad won't automatically sort of mark congruent things congruent. That's something to be aware of. You have to be the brains behind the marker tool for the most part. So I have to say, okay, I'm marking this angle with 3, and I know that this angle is the corresponding angle and that it's congruent, so I'm also going to mark it with 3. And if I click on that angle, it'll go from 1, 2, 3, 4 rings back to 1. Okay. I can also use the marker tool to mark parallel. What I do is I right-click, or you can control-click, and then I get a choice of whether to use a crossbar, an open arrow, hollow arrow, or solid arrow. So if I changed it, I could get the parallel mark. But in this case, that's not very relevant. Okay. So that's a little sort of preview of the marker tool. You can also just use the marker tool to write. So if you're on an interactive whiteboard, you can write. And it might look better than that when you write. Probably not, though. Anyhow, so it can be used just to write on your, if you have a smart board or whatever kind of interactive whiteboard, you can use that marker tool. Okay, I'm going to delete that lovely hello. Okay, so I've just reflected across the y-axis. You can do the same thing to reflect across the x-axis, but sometimes you want to reflect across the line, say y equals x, and so I want to show you a little sneaky trick that you may need to use. I'm going to go ahead and delete this reflection. So in Sketchpad, we have the ability to graph functions, so I can graph the line y equals x or f of x equals x. But we have a bit of a problem in that we cannot mark a function to be the mirror, to be the line of reflection. So you have to work around that. And I'm going to delete this function. And one easy way to work around it is to construct a line instead of graphing the function y equals x. So I'm going to plot the point 2, 2. And now I'm going to use my line tool to construct a line that goes through the origin and through 2, 2. And because I was a math teacher for many years, I know that that line is the line y equals x. And now I can mark it, because it's a constructed line and not a function plot, I can mark it as a mirror. Again, you can choose it from the menu, or you can just double click it. And then I can select my, oops, let's not select the measure though. I can select my triangle, and I can reflect it. Okay, and this guy's getting kind of out there, so it's hard to see. Okay. All right, so that's a little trick for reflections. For rotations, I'm going to also show you kind of two ways to do it. And okay, quadrilateral. Okay, and you can tell by the way my points are moving that I still have snap to grid on. Again, you can turn that off or on depending on what you want to do. Okay, so in order to rotate a figure, I need to choose a center of rotation, and since we're working in the coordinate plane here, the origin is kind of a natural choice. So I can either select that point and say mark center, and it will look like a bullseye, or I can double click and get that same bullseye effect. That tells me that that is the chosen center. And then I can select my figure and rotate, and I will get the choice of the angle of rotation. I'm going to say 100 and, let's see, whoops, 180. And I can rotate it. And just like my other transformations, if I change the original figure, the image there will change. So that's a fine way to do a rotation when you're looking at sort of particular values like rotating by 90 degrees, 180 degrees, and so forth. But I sort of want to see everything in between. So to do that, similar to the way that I used the translate by vector here, we're going to create an angle that we're going to use for our angle of rotation. And I am, you do not need to make a circle to do this. This is kind of my preference. I like the circle because it just keeps things a little neater. So I've made a circle, and I'm just going to hide this point on the circle. Makes the circle bigger or smaller. I kind of want my circle to stay about this size. So I'm going to hide point R. And I'm going to use the segment tool to basically create an angle. And I can drag point T around the circle, and it will stay on that circle. And I'm going to select that angle by marking it as my angle of rotation. Hopefully you saw it go. I'm going to show that again. So I selected it, and if you watch the angle down there and I choose transform, you can see it kind of ripple around the angle. Now when I choose my image and I choose rotate, it's going to come up with marked angle, SQT, and I can control that rotation just by dragging point T around the circle. And that's pretty cool. Okay. Now, I have to say that I really kind of lose track of the figure. I don't know how else to put that. So there are a couple of tips that I used to use with my students that kind of helped me understand the orientation of a rotated figure better. One thing that helps me is to actually connect one vertex of the figure to the origin and one vertex of the rotated image, and then I can kind of see that connecting segment and see how it's rotating. So that helps me just visually see what's going on. I'm going to delete this guy for now. And then another thing that might help is you can trace one or all of the vertices of the figure. And so as I rotate again, I can see that vertex M prime is keeping its distance from the center of the rotation, right? I've just made a circle there, tracing it out. For those of you who are really just very good at visualization, this may seem sort of like overkill, but it's helpful for me, and I think it was helpful for a lot of my students as well. Okay. Oh no, time is running past me really quickly. Questions?
Not just like what point was it rotating around, but it was the point of origin.
Right.
Maybe explain how you did that again.
Yeah. So if I selected, and I did this at the very beginning, I should have reminded you. So I select the origin, and I can choose it as the center, and it will sort of do the bullseye, or I can double-click that point, and it will choose it as the center. And I don't have to choose the origin. I can choose any point to be. So in fact, if I chose this to be the center of rotation, and I now rotate again, notice what's changing there, right? Oops, I should probably say rotate. Ooh, I don't know what I just did. I think I selected too many things. Oh,
it's very pretty though.
Like, I don't know.
Like kites.
Yeah.
There was a question. How'd you get the traces to fade?
Oh, great. Okay, so I'm going to the Edit menu, and I'm selecting Preferences. And this is a great menu to know about. It does all kinds of things, like you can decide whether to show labels for points automatically or not. Under Color, you can either fade traces over time or not. Sometimes you want to keep the traces, and then you can choose whether you want them to fade quickly or slowly. So if I put it at the very slowest, I better select this again. And is it? I don't know if it's still, yeah. So it's still tracing, and now I have another thing rotating in there that I accidentally did. So they're set to fade slowly, but they will fade. I can also, again, edit preferences, set them not to fade at all, and then, I'll actually have a circle that will stay. It's very colorful.
Okay,
and that extra
we have a couple questions about the angles. So what about, for example, positive and negative angles, and can you actually show the angle measurement at the origin for those two?
Yeah, so let me clean this guy up a little bit, and going to, I want to, one thing you notice that the trace point is checked. I want to uncheck that, and then I want to find that rogue triangle. Delete that.
I like rogue triangle.
Or actually, it's a quadrilateral, huh? Keep calling it a triangle, but it's a quadrilateral. So we can measure, and I'm glad that question came up because it looks like I'm probably not going to have time to show everything. So right now, you can, if you watch that measure, when I flip past 180 right here, it's counting down again. I can change again in preferences. I can change my preferences, and under units, change that to directed degrees. And then when I rotate T, what's actually going to happen is I'm going to go into the negative. But notice I'm still going all the way around there, right? My rotation is still going all the way around. And if I wanted to, I could measure this angle as well. let me think about the direction there. Well, let's see what happens. Okay. So you can sort of see the connection there. Now, I don't believe there's a way for me to go from like 0 to 360. If Andres or someone wants to address that if I'm wrong, we can go to radians when we want to really start dealing with circular angles, but the choices in degrees are just degrees or directed degrees.
Yeah, I don't think I've ever been able to make it go beyond 380. I mean 360, you know, show 250 or something like that, so no.
Yeah. So, I'm a little sad. I'm sorry I must have been talking a lot because I'm like halfway through what I wanted to do, and we are more than halfway through the time. So, I'm gonna show a couple activities. The good thing is the rest of this is all I'll give you the worksheets and the teacher notes. So, and they're very they give you all the steps. So.
Can I interrupt you for a second? Because Andres just gave us an answer to the angle. He said you can make an angle marker that's set to be counterclockwise, and you will get the. So again, this is the marker tool that she's using to create the angle mark.
So in properties, is that where I do it?
I don't know. I'm waiting for Andres to answer.
Here we go.
A reflex angle. Yeah.
Okay, so I want to go.
Well, I've just learned something new. Good to know.
Okay, but that doesn't affect the angle measure, right? Or do I have to change it back to degrees now?
He said measure the angle. Measure the angle mark. You have to actually measure the angle mark.
Measure the angle marker. Oh, look at that.
There we go. So it has to do with selecting an angle mark.
How pretty that is. So now we can go 0 to 360. Okay,
awesome.
So to review
Thank you, Andres.
So that I'll remember it, I can either control-click or right-click, depending on whether you have that kind of two-button mouse, and select Properties. So click on the angle marker, select Properties, go to Marker, and then we can choose counterclockwise. And I could also change the appearance there, right?
Yes.
And then measure the marker instead of the angle. And now I've got a 360-degree measure, and it does start over again at 0. Okay, very cool.
Very cool.
Excellent.
Excellent. I always
All
love
right. Good thing we have a rock star in the office. Okay. So this is a high school standard. Given a rectangle, parallelogram, trapezoid, or regular polygon, describe the rotations and reflections that carry it onto itself. What's so cool is that we have an activity that I'm giving you that does exactly this. And I will be giving you, in addition to this sketch, I'll be giving you a sketch called Polygons that has some custom tools, and that's what I'm using right now. I'm going to go ahead and make a regular pentagon inscribed here, and if I just click twice, that's enough to construct a regular pentagon using that tool. So I'm going to first investigate reflectional symmetry. I'm going to hide that to make some space. And so to do a line of reflection, I need to construct a line again. And I can double-click, or I can choose the line and mark it as a mirror. And I'm going to select just the interior of this polygon, and I'm going to reflect it. Now, the idea here, and this is in the worksheet, is what I want to do is move my line of reflection so that the reflected image exactly corresponds to the original. And to make it a little easier to see, I'm going to swap colors there. So I can sort of see, okay, I obviously need to move it closer. And if I just experiment, I can see that if I move my line so that the line passes through the vertex and the midpoint of the opposite side. And one way to make this a little easier is if I actually bring the point of the line right down there. And now I've gotten it to correspond exactly. And the worksheet asks students to find all the lines of symmetry, and you can see that I could basically sort of work my way around from vertex and midpoint to the next vertex and midpoint to find all 5 lines of symmetry for that regular pentagon. And I would record this on the worksheet. When I've done that and described, my method for finding the lines of symmetry, I'm then going to explore rotational symmetry. So another chance to see how rotation works, I'm going to select this point and transform mark center. And again, I'm going to select the interior. Oh, I think I just skipped a step, didn't I? I think I want to choose an angle of rotation. Now, I'm going to this time just construct an angle using the segment tool, and that will explain to you why I like using this circle. Okay, so this is an angle, and I'm going to mark this as my angle of rotation. And now again, I've chosen this as the center of rotation. I'm going to select the inside of the pentagon, and I'm going to rotate, and it says by marked angle, which is this angle. I'm going to rotate and change colors of the rotation there so I can see what's going on. And now this angle controls my rotation. The reason I like building the angle on a circle better is just because I tend to sort of I don't have a very sure mouse hand, I guess. So when it's on the circle, it stays nicely on the circle. When it's out here, it's easy to sort of move this point around and without changing the angle, really. Okay, so now I can see, and again, I should probably measure that angle. That will be helpful. And I'm going to use Andres' trick. So I'm going to go mark the angle. I'm going to measure the angle, and I'm going to right-click on that guy, and I'm going to make it counterclockwise. Oh, I wonder if I have to remeasure it. Let's see. Nope, it's working perfectly. Okay, and now I can take a look at when the image coincides with the original figure. So at 0, they coincide. My angle measure disappears because there's no angle. And when's the next time that they coincide? And I hope that it's around 72, etc. So again, students are looking for the rotational symmetries there, and they have to record the angles. And they do this. This is an activity where you could divide it up among groups and have one group look at an equilateral triangle, one group look at a hexagon, one group look at a square. You can see all the options there for constructing regular polygons. And what's cool about this is once I've made this discovery about the symmetry, I can actually use that relationship to construct my own special tool. So I noticed that the rotational symmetry happened every 72 degrees for this pentagon. So I'm going to go ahead and construct my own regular pentagon using that property. So I'm going to construct a center point, and I'm going to construct a starting point. Now, again, I'm going to double-click this to choose that as my new center, and I'm going to click my starting vertex. I'm going to rotate it, and this time I don't want my marked angle. I'm going to choose 72 degrees. And now I'm going to take that rotation and I'm going to do it again, rotate again, 72 degrees, and you can see where the next rotated point is going to land. I'm going to do that again. And again, you can see the image there. And then one more time. Okay, if I use my Polygon tool, I can construct a polygon using those 5 points as vertices, and I can see that no matter how I drag, it is going to stay a regular pentagon. And now, here's the really cool part. I can create a new tool called Elizabeth Reg Pentagon. And now I can just click 2 points and I'll get a regular pentagon every time. So that's the cool thing, is when you start to discover mathematical properties with Sketchpad, you can actually use the properties to, to do constructions. So that's a pretty neat power. Okay, so this activity that we were just going through is called Symmetry and Regular Polygons, and I gave you the student worksheet, but I'll also give you the teacher notes for that. There are 2 more activities. They're called Similar Polygons and Similar Triangles, and they are about the same sort of level of difficulty. You do start from a blank sketch each time, but the activities take you through step by step how to do it. Should I take 2 minutes and do a quick overview?
Well, how about we do this? Technically, time is up, but we are perfectly happy to keep on going. So if you have to leave, we understand, and that's great. We are recording this, and we'll put the full recording up in its entirety. But if Elizabeth's willing to keep on going for a little bit more, we'll let her do that. And if you can stay, that would be terrific. We would love to have you stay.
Yeah, I'm just going to take maybe 3 minutes. I'm not gonna do a lot, but I want to make I want to show one thing, because it's 2 ways to do a dilation, and we really haven't talked about dilation. So I will show this, and then we can take some more questions. And again, if you have to leave, I totally understand. I apologize for apparently talking slower than I did when I was practicing. Okay, so I've constructed a quadrilateral here, and this time we're going to be looking at dilation. So we're not looking at congruent figures anymore. But just like with rotations, you have to choose a center of dilation. So I'm going to double-click that point, and I've now marked it as the center. And I'm going to construct 2 segments. And don't worry, the steps for this are in one of the worksheets that I'm giving you, the Similar Polygons worksheet. And I'm selecting both of these segments, and I'm choosing, under the Transform menu, Mark Segment Ratio. Okay, so that's going to be the ratio of my dilation. Now I'm selecting the polygon, choosing Transform, and when the Dilate menu comes up, it says by marked ratio, FG to HI, so that's correct. And now I can see the dilated figure. Okay, and it's cool because I can control the dilation using either one of these segments, but I'm going to use the shorter one here because I'm sort of looking at fractional ratios here. If I want to actually see what that ratio is, I can select the 2 segments and measure the ratio. I don't even really have to know the lengths, I just know the ratio. And then I can explore where else that ratio comes up. For example, if I measure 2 corresponding sides there and I measure the ratio, I'm going to see that 0.56 over and over again. And if I vary the dilation ratio, then you can see what happens to the dilation, the dilated figure. I'm going to hide the labels because it's getting a little crowded there, and want to show a couple things that are neat for students to explore. One is that if I move the center of dilation to one of the vertices, I can actually directly compare the angles there and see that that the corresponding angles are congruent by actually superimposing them. I think that's really neat. Okay.
Elizabeth, there's a question about the segments. Is it possible to make them be number lines and label the units so the students can actually see the ratio?
Ooh.
Is that like a directed distance?
That would be something that we'd need to sort of have a pre-constructed sketch to do. So in other words, I've just built this in 30 seconds. That would take some special tools. So yes, it's possible, but we'd need to build it, and I can sort of think about how to do that. I can't sort of come up with it on the spot, but that's a really good idea. Yeah. I just to kind of finish off the idea of this activity, one of the things it asks students to do in an Explore More is actually connect the center of dilation to each point of the figure. And you can see I'm connecting them to the dilation there, but they also pass through the vertices of my original figure. And that's a really neat kind of look at the projection there, I think. Give you a really nice visual understanding of a dilation. And then I just want to show one other technique for doing a dilation before we close. And that's, I'm going to go ahead and construct a full line, and I'm going to put a point on that line. And I have the point selected, and I'm going to measure its value. And you can see this measure comes up, and basically when I constructed the line, Sketchpad automatically considers the first point to be 0, the second point to be 1, and then the value of this point is, you know, sort of, it's based on its distance from 0, between 0 and 1. So I can use this value as my scale factor as well. And so if I, again, choosing this as the center, I'm going to hide these lines for a second. If I select my original figure and choose dilate, it's now going to be by this marked ratio. And now I can affect my dilation by dragging this point L along the line. I think the advantage of this is that, well, I can go negative, and I can go greater than 1. Of course, I could do that by dragging FG greater as well. But I actually, I think for younger students, I kind of like this, the 2-segment approach, because I think it really helps you understand the ratio of corresponding sides and how it relates. Kind of curious to know what people think about that. This seems more advanced to me, a little bit more conceptual. So anyhow, either works, but you might want to think about which would be more effective depending on the age of your students. So that is a very quick overview of the similar polygons activity. And then the other one I was going to do is similar triangles, but I think that one, you know, it's very, very step-by-step in the notes, and won't really add any additional information. So pause for questions, and then we will wrap this up a little late.
I'm getting a message from someone that says the materials aren't available anymore. I'm still seeing them, so I'm not quite sure. But the materials, all the materials are going to be up with the recording. So we usually have it up by Friday, and so all the materials, including the sketches, I believe Elizabeth said she was going to share with the Polygon tools and such. So all of that will be up by Friday if you didn't get it tonight, and the recording and everything will be up as well.
Yeah, so I'm going to save this sketch that I've just been working on. I'll probably add a couple notes and tips in it, and we'll give you this sketch, that Polygon Tool sketch, and then the worksheets and also the teacher notes that go with them. So all that will be bundled up together and posted with the recording.
Okay, well, thank you all for staying late and for joining us this evening. Thank you, Elizabeth. That was terrific. And I thank all of you giving us suggestions for future webinars. So hopefully we'll have some ideas for the future. So make sure you check our webinar sites for the recording and for upcoming webinars as they come up. And thanks again for joining us. Thanks, Andres, for helping with questioning. And thanks again, Elizabeth.
Yeah, thanks to all of you for coming. And thanks to my question answerers and MC.
Okay. Good night, everyone.
Have a good evening, everybody.